Okay, good morning, everyone. And in India, is it afternoon or is it still morning? Yeah, afternoon to you guys. My name is Luiz da Silva. I'm a professor at Trinity College in Ireland and also at Virginia Tech. So I currently have two affiliations in the US and in Ireland. And I'm very happy to be here and spending these few days in Aalborg. And I have three presentations to give. Two today and one tomorrow, so by the end of tomorrow you'll be sick of hearing from me. And I encourage you to ask questions as we go along, so if you have anything that you want to ask, just interrupt me. Let's not wait until the end. So just a little bit about me. I was born in Brazil, in Rio de Janeiro, in a place called Ipanema, and that's a picture of Ipanema in the 70s.
That's a very nice place.
Yeah, it's a nice place.
Because of the song, right?
Yeah, exactly. So there's a song, "The Girl from Ipanema," which was written about this woman in the 60s. Turns out she is a cousin of my brother's wife, so we are kind of related. So anyway, that's where I grew up, and then I moved to the U.S. when I was 16 to finish high school, and then kind of went back and forth. But spent most of my life in the U.S. And since '98, so for the past 14 years, I've been in the faculty of Electrical and Computer Engineering at Virginia Tech. And then 3 years ago, I moved to Ireland. I moved to Trinity College Dublin, and I spent 2 full years there, and then I started to divide my time between the two places. So nowadays, I live somewhere between Ireland and Washington, D.C. in the U.S. And this morning's lecture is about radio resource management. So I'll talk a little bit about the objectives of radio resource management, and then, does this work? Yeah. Then some approaches for how wireless resources are allocated, and a couple of functional architectures for cognitive radio resource management. And then if anyone dies of PowerPoint poisoning, please don't blame me. It's what can you do? You need to have PowerPoint nowadays. So I tried to do a mixture of some higher level concepts and some examples that are more specific. If it's too general or too specific, just let me know. Okay, so what is radio resource management about? The idea is that in a wireless network, you have some resources that end up being shared by multiple users, and you have to find some way to share these resources reasonably. So, for instance, you can allocate orthogonal channels to different users, and those channels can be in frequency and time, in frequency and time, if you think about something like OFDMA, or in code if you think about something like CDMA. Or at least if the channels are not truly orthogonal, if there is some amount of interference tolerance, you want to allocate resources so that the users are not too much in each other's way. And you will do that through things like transmit power control and the allocation of channels in the network, the allocation of spectrum, in general, the sharing of spectrum, the scheduling of the medium through some medium access control method, either random or not, through the scheduling of multi-antenna use in the systems, which is becoming increasingly important with LTE, for instance, and in the use of multiple transceivers in the same node. So more and more we're seeing these radios that are equipped with transceivers to enable them to communicate with multiple radio access technologies at the same time. And there may be some amount of resource management across these technologies so that the radio moves in between those different radio access technologies in a seamless way. So to do that, you have to consider both the goals of the radio itself and the goals of the network. And sometimes these work in tandem, sometimes these are conflicting. So the radio itself wants to maximize its signal to interference and noise ratio. wants to maximize its data rate when it's transmitting data, wants to maximize its throughput, ultimately, wants to mitigate the effects of interference and noise. So sometimes you hear people say that in wireless networks and wireless communications, we should be amazed that anything works at all, right? Because there's just so much that can go wrong, and so many effects that are going to decrease the quality of the signal. So the radio wants to mitigate these effects through whatever means it can, through diversity, whatever it wants to do to achieve that, guard bands and so on. It wants to maximize its access to a shared medium, so wants to get the biggest share of the medium it can, assuming, of course, it has traffic to transmit, and it wants to maximize its battery life, so minimize the energy consumed. The network, at the same time, wants to make the best use possible of spectrum resources. So Andrea talked a lot about spectrum, dynamic spectrum access, and regulation, etc. yesterday. So the network is trying to maximize the efficiency of the use of this spectrum, which of course is a very expensive resource from the regulator's point of view. They want to keep users happy, so they want to maximize the aggregate throughput, avoid too much contention for resources that may end up wasting a lot of the bandwidth through just overhead, and it wants to ensure the appropriate coverage for all of its users. So what you want to do is to see how, from the point of view of the network and the radio, and sometimes from the combined point of view of the network and radio, how do we allocate resources in the best way possible? Okay, so just to make mention of this idea of aggregate throughput and data rate and so on and so forth, and to tie back to some of the discussion yesterday that I heard from Andrea here. So it's becoming a bigger and bigger problem, this idea of trying to fit all of the user demand into the amount of spectrum that these networks currently have. So it's almost a cliche to say, okay, we're going to run out of spectrum in so many years, but all of the studies show that we are going to very fast run out of spectrum. And we're starting to see this happening in some places. So it's not just an alarmist idea of something that may not come to pass, but it's actually already happening. So there is a famous case in New York City that I don't know if you followed, but it made all the newspapers. The New York Times had a couple of articles that I thought were kind of interesting about how the prevalence of the iPhone among people who live and work in New York City has led to an increase in the demand for data rates, which led to the operators not being able to meet that increase. So for a while, the only operator in the US that supported the iPhone was AT&T Wireless, and it simply did not have the resources to meet the demand that they had once they had a very large population of iPhone users. So for a while, they came up with a solution to try to meet this demand, which is a form of radio resource management, but not one that I'm going to talk about today. But did anyone read about this solution? Very clever solution. They stopped selling the iPhone in Manhattan. So that was their solution. In the island of Manhattan, they wouldn't sell iPhones anymore. Of course, you could still buy an iPhone in Bronx, or in Brooklyn. So you just took the train outside of the island and you bought an iPhone and you brought the iPhone back to the island. So it didn't really solve very much. So sometimes you see radio resource management in ways that are not quite technical, but which we'll not talk about. Okay, so those things, trying to maximize data rates, signal to interference noise ratio, optimize use of spectrum, etc. That's really true for any wireless network. What may be different in terms of cognitive networks? So why cognitive radio resource management? So I don't want to go into a big debate about what is cognitive radio and so on. I think Andrea already did a very good job yesterday of discussing that. And I don't think it's very useful to try to go into a lot of detail. So I'm meaning cognitive in kind of a broader sense. So in a way, one thing that for me really characterizes cognitive radio is the ability to reconfigure. So the ability that the terminal has of reconfiguring in real time and to a varying wireless environment. And that could be a combination of things, a combination of frequency agility and adaptive modulation and encoding, and the ability to shape the signal to fit the existing spectrum, etc. But in general, a much greater ability to reconfigure. That changes the equation in terms of radio resource management, because now you can also count, even if the radio resource management is being done by the network, you can count on the radio's ability to actually not just do one thing, but to kind of shape itself to the resources that are made available to it. So I think the first one is, in my opinion, like the big one that differentiates cognitive radio resource management as a problem from just regular radio resource management. But the second one is also something that we see increasingly, right? We have these radios that now are capable of working with multiple radio access technologies. And then once you have that, you can think about jointly optimizing the use of these radio access technologies as a radio resource management problem. Then there is the idea of frequency agility, that most cognitive radios that when we think about cognitive radio, we usually think of a radio that actually can jump from one channel to another and even use varying amounts of bandwidth. And maybe even doing that opportunistically, so coexisting with some primary or incumbent user of the spectrum. So you might have a primary user that's allocated a certain band, and then the secondary user that's using that band opportunistically. And now the cognitive radio resource management, from the point of view of the secondary user or the secondary network, needs to take into consideration the usage patterns of the primary. So it changes the problem. So I think those are the things that make the problem of radio resource management in cognitive radios different from what we have had in the past in wireless networks in general. Now, the approaches to try to solve the problem are not necessarily different, and we'll look at some of those approaches in a minute. Okay. So, in cognitive radio resource management, what you want is a more dynamic allocation of resources. So rather than a static allocation of spectrum, multi-antenna use, whatever the resource you're talking about, you want to do that dynamically according to usage patterns, demand, maybe the patterns of usage by some primary user, etc. And you want to do that keeping in mind that now these radios have an increased ability to adapt and to reconfigure themselves. We may also expect some higher degree of autonomy from the radios. So yesterday there was a lot of discussion about whether the intelligence should reside in the radio or the network and so on. And you see different architectures where you put the decision-making in a different place. So sometimes you assume that the radios can make a lot of the decisions autonomously. Sometimes you assume that everything is done by the base station. The base station tells the radios what to do. But at least in some situations, you could expect the radios to participate more actively in this decision about the use of resources, rather than just waiting to be fed by some access point or base station the decisions of what resources they can use. We may also be dealing with the problem of coexistence, so a certain amount of competition and cooperation in the use of resources. We see that a lot in the context of dynamic spectrum access, where a secondary user needs to coexist and respect the priority access on the part of the primary user, and then the secondary users compete among themselves for opportunistic access to that spectrum. So they need to also cooperate. They compete for access, and sometimes it's actually advantageous for them to cooperate with one another to end up getting better access for everyone. And part of this problem may also be the allocation of traffic to different radio access technologies. So once a radio is equipped with the means to connect to multiple networks at the same time, you may be able to take advantage of that and assign traffic to these different radio access technologies, and that becomes a cognitive radio resource management problem as well. A lot of the examples that I'm going to give are going to be in the context of dynamic spectrum access or flexible management of spectrum, because that has gotten the most attention